Okay, today we're looking at solving system of linear equations by the method of graphing. Now, in order to use the graphing method, what you want to do is that you want to recall the slope-intercept form y equal mx plus b, because what you have to do is that in each of the systems, such as the two given here, each of the equations must be in the slope-intercept form like this. So for the first example that we have to do, we got x equal negative 2y, see it there, plus 4, and then 3x minus 3y equal to 6. Now, these two equations are not in the y equal mx plus b form, so I have to solve for y, and then I have to rearrange everything in order of something, multiply the x, and then plus something else. So for the first one, for the first equation, what I can do is that if I just add 2y to both sides and then just subtract x at the same terms, I would be getting closer to what I want. So cancel out the 2y, cancel out the x. That means my new first equation will be 2y equal to negative, I'm gonna write negative 1x, okay? It's easier to see, plus 4. And then for my second equation, well, I'm gonna add 3y to both sides. And then I'm gonna subtract 6 to the left at the same time. So that means I'm gonna have 3x minus 6 equal to 3y. Now, why is it that, you may ask, oh, why is it that on top you move the y to the left, but then at the bottom you move the y to the right? Well, it's because I want to make sure that the coefficient that goes with the y is positive as much as it's positive all the way through. So that when I eventually divide everything by that coefficient in each of the equations so that y can be by itself, it's easier to divide everything by a positive number than a negative number. Although it is still okay to, divide both sides by a negative number, but I just prefer to work with a positive coefficient instead, okay? Now in this case, in the first one, I got 2 times y equal negative 1x plus 4. Well, I want to solve for y by simply getting rid of 2 by dividing everything by 2. That means my new first equation, or the final form, my first equation is going to be y equal negative, I'm going to put negative 1 like this, over 2 times x. And then we got 4 divided by 2, that's going to be 2. And then for the second equation, if I divide both sides, everything by positive 3, my new second equation would be y equal, well, let's see, 3x divided by 3 is just going to be x itself, but x itself is the same as 1 over 1. And then negative 6 divided by 2 is going to be minus 2. All right. Now, why is it that I write my slope in fractional form? Because it is easier for me to recognize how many units I have to go up or down first, and then how many units I have to go left or right later. So not only that, by placing by placing the minus sign or the plus sign with the appropriate numerator or denominator, that's going to make it even more clear in terms of whether I should go up or down or left or right by however many units, okay? So for the first equation, I'm going to call it capital A, and the second equation, capital B. Well, if I were to draw a graph, and this is going to be a rough sketch, so I do apologize if my drawing is messy. So this is the x coordinate, and this is the y coordinate. So I'm going to scale it by 2. let's say 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, -2, -4, -6, -8, maybe just a little more. You can see that. -8, -10, -12, and something on the left here. I got -2, -4, -6, -8, -10. Okay, so for the first equation, let's graph A. Well, my y-intercept is +2, so +2 is here. Okay. 1, 2, 4, 6, 8. So +2 is here. Now, starting at the y-intercept 2 in the A equation, my slope is -1/2, so that means rise over run. Go down 1 unit and then to the right 2 units. So go down 1, so basically I'm gonna end up at 1 right here, and then to the right 2, so boom, right there. So basically 1, 2, and of course halfway from here to here it's going to be 1 because we are scaling by 2. So 1 and 2. And then just repeat the same procedure. Go down 1 to the right twice. Go down 1 to the right twice, like that. Okay, and then if you keep going, eventually you get a bunch of more dots. But this is supposed to be a straight line, so just imagine it is a straight line, like that. And of course, if you go this way, just go the opposite. And that's how you sketch out one line. So this is line A. Now line B, same procedure. You got the -2. I mean the y-intercept is -2, so -2 right here. This is -4, -6, -8, -10, -12. Starting at the y-intercept -2 for the B equation, my slope is +1 over +1. So again, rise over run, go up 1 unit, and then go to the right 1 unit. So you go up 1, which is -1, and then you go to the right 1, which is at, oops, I mean, my bad. I mean, that means you go up 1, then to the right 1, right there. Go up 1, to the right 1, right there. Go up 1, and then to the right 1. So this is 3, and then if you keep going, you sketch out a second straight line, like that, right? So this is the point of intersection here, and I'm thinking this is going to be, it seems like the x and the y coordinate is 5/2, comma 5/2, comma 1, I think. Okay, but if you're not sure, just go ahead and plug it into the website called desmos.com on top and type these two equations in that website, and they'll show you the graph of this. Okay, but the overall idea is that the solution to the system of linear equation is just a point of intersection of two straight lines. And this is just another method in addition to the methods of substitution and elimination that we can use to solve for the system of linear equation.